So then, and there will be a junction box. The function of junction box is this export the solar cell generated electricity through a cable for further use. Actually, why I am telling this, we are going to model so that we can recycling this thing. So before recycling it, we know what are the things why we need the recycling of that. Not it. So otherwise, as a student of mathematics, I don't need this kind of things. But before doing something, we need to know what is there and how we can make the recycling so that we can find maximum from that recycling module. We are not here managing, or we are not here just garbaging that or destroying that, because there are so many important materials so that we can reclaim that. Now, a solar cell, also known as photovoltaic cell, is an electrical device that transforms light energy to electrical energy using the photovoltaic effect. Now, that is physics behind that. A solar cell is made up of two types of silicon semiconductors. I think is there any student of physics here? So you can understand better about this, or electric, if some electrical engineers are there. So a solar cell is made up of two types of silicon semiconductors. One is N-type silicon semiconductor, and that is P-type silicon semiconductor. Then there is anti-reflective coat covering the solar cell to prevent any external shock. Then the solar cell middle layer is also known as PN junction diode. Now, when the sunlight falls on the solar cell, the solar energy from the sun in the form of photons creates loose electrons on the N-type to P-type. Then these created loose electrons are collected. These created loose electrons are collected on the aluminum layer and start flowing, thus resulting the generating of the energy from the sun in the form of photons. Now, different types of solar cells are there. One is monocrystalline solar cell. Then this is monocrystalline solar cells are cut from a single pure crystal of silicon, collected on the aluminum layer, assembled into rows and columns, thus resulting a rectangular cover energy with a glass sheet and film. We have already seen how they are covered. So monocrystalline solar cells are black, appears black because of how light interacts with the pure silicon crystal. Have a variety of colors for their backsheet and frame. So we can see different color due to this. Now, polycrystalline. The silicon is melted and poured into square mold like this. They are first melted, and then we are getting this kind of square sheet. Then monocrystalline solar cells and polycrystalline solar cells vary in composition of the silicon itself. Polycrystalline solar cells are composed of fragments of silicon crystal that are melted together in a mold before being cut into wafers. Then these are some basic things. We are not that much interested. Then the third type is thin film solar cells. So thin film solar cells are made up of variety of materials like amorphous silicon, cadmium telluride, copper, indium, gallium selenide, etc. So this is again, as the name indicates, thin film solar cells are often slimmer than other two types, monocrystalline and polycrystalline. The manufacturers place the layer of CTD, that is cadmium telluride, between transparent conducting layers and help capture sunlight, so that maximum sunlight can be captured. Now, there is bifacial solar panel. So both sides we can be sure from the name that this is bifacial, both way we can get, so that if we know, if we can put in some place that both sides it can find the energy from both the sides. For that type of place, we need bifacial solar panel, but it is costly. Now, instead of covering the backside of normal PV panel, here it is made there transparent so that both faces can generate electricity. Not suitable for rooftop, because if you put in rooftop, so it will just lose your money, because it is not required in rooftop, because if from below side there will not be any sunlight. Okay? So ideal use case for bifacial solar panel is in commercial and utilities scale solar installation. Then operation we can see. Now these are some the advantages and disadvantages are there, monocrystalline and solar. So you can see this. The main disadvantage of bifacial is it is high cost and heavy alloy. Now this is solar grid system. Now there is a mission from Government of India, you know, everyone is just to put in the rooftop or the solar panels in the rooftop. So how it works? So from solar panel, from inverter, it changes its current system. Then it is from electricity meter. Then you can use directly in your house. Otherwise, you can put it into electricity grid so that yes. So now advantage. What is the advantage? Main advantage of solar photovoltaic cells. First, this is a huge renewable energy source, and it will never ending renewable source. It will not end in our lifetime or in the lifetime of our Earth. Then no pollution, zero emission, no greenhouse effect during energy generation, no maintenance cost after installation, very low or nil operating cost, last for a long time, suitable for remote and off-grid access, and scalable technology. Okay, so there are a lot of benefits using this solar panel, getting power from the solar panel. Now, why? What is the current status of solar panels worldwide? Now, in 2024, cumulative solar PV capacity reached some 886 gigawatt in China alone. So, you know, China per day, there was a report, per day they are putting this much of solar cell, it is bigger than Switzerland. Per day installation, their per day installation of solar cells. So that is the that's in that rate they are putting their solar cells apart, because we know one part of China, several part of China, there are very less human beings. So they are putting their every day they are putting these solar panels in those areas. So in 2024, cumulative solar PV capacity is some 886 gigawatt in China alone. The total installed capacity of solar PV reached 1,865 gigawatt globally by the end of 2024. So representing a remarkable increase on from 710 gigawatt was there in 2020. Right now in 2024 it is 1,865. So and out of this, so how many? What is the increment? Almost say 1150, like 1150. So out of this, the 415 gigawatt of new solar PV capacity was added in 2024 alone, only the last year. So now together solar PV and wind energy accounted for 96.6% of all renewable energy. Now with 1865 gigawatt solar PV now accounts for over 3/4 of 4448 gigawatt global installed renewable energy. So total renewable energy right now, right now means it is in the end of 2024, is 4448 gigawatt. And out of this 4448 gigawatt of total renewable energy, the part of solar energy is 1,865. So you can find how much, what is the percentage of this. Now the UK solar capacity has exceeded 20 gigawatt at the end of 2024, and it will be in 2025. It will be surpassed. Already will be added 18 gigawatt addition. Then Vietnam, these are some just numbers. Vietnam is 16.5, Singapore installed is 200 megawatt and 350 megawatt. Then for this is 2025 to 29. Solar PV capacity additions worldwide are forecasted to be between 655 and 930 gigawatts annually. So this will be added in every year. Now, India, what is the status of India? In 2010, this was only 0.07 gigawatt, and in 2014, it was 3.78 gigawatt. So from 2014 to 2018, this is from 3.78 to 23.29 gigawatt, and in 2022 it is 54.94 gigawatt. So in 2023, the just install capacity is 67.72 gigawatt, and in which is elevated to 90.76 gigawatt in 2024. So right now we are just getting the pace. We are coming slowly but speedily. Now this is the graph, the install capacity in India. Now our what we are thinking about, why we are here, to see the solar waste. We are managing, we are here for recycling the waste. So what is the condition of the waste? So what are the waste? First thing, so there will be a lot of waste in manufacturing this and implementing this solar energy. So there are some part of this waste are stages of this waste is started from the manufacturing stage. So first is manufacturing stage, there will be a lot of waste in manufacturing waste. Then in transportation stage, then operational stage, then end of life stage, and then decommissioning stage. Now the lifespan of SPVM, this is solar photovoltaic module, is 25 to 30 years. Now the amount of waste volume which will reach nearly, now see, 13.5 to 20 million tons in China, 7.5 to 10 million tons in US, 6.5 to 7.5 million tons in Japan, and more than 4 million tons in Germany, nearly 4.5 to 7.5 million tons in India by 2026. Now see these huge waste, what will do? How this will be managed? And that will just devastate all our environment if it is kept somewhere. So generally what we are doing, we are filling some land with this, or we are putting it under our oceans. So everything will get destroyed. All ecology, all environment will get destroyed if this cannot be taken care of. So we can see the condition. Now, so what they are containing, so that we are interested in their recycling. First, the solar photovoltaic modules contains lead, cadmium, copper, and what, etc., which may contaminate. This first, let us see the contamination. Okay, so these are contaminate the soil and water. Then waste PV modules contain valuable. These are which will first part is which will contaminate the environment. The second part is waste module contains valuable material like aluminum, copper, silver, silicon, and glass. So we have to reclaim those things. So recycling panel allows recovery of these materials, reducing the need for virgin mining. Different recycling process exist, but commercial scale PV recycling module is very limited. Then avoid toxic emissions during improper disposal through burning or baking. Then recovering, now the main thing is recovering these materials, the indium, tellurium and gallium. So these are some rare earth material. We know that in whole world now a huge geopolitical actions is going on about this rare earth material, because China is captured almost 80% of or 90% of rare earth material. So now what to do? Because if they stop the supply chain management, we cannot do anything. We cannot even manufacture anything. So there is a huge shortage of this rare earth material in whole world. Again, so how to reclaim this rare earth material so that we can work in future. So about first recovering material like indium, tellurium and gallium, reducing dependency on imports. Then arsenic and germanium are found in high efficiency space red matter. So these two are again, we can get arsenic and germanium. Arsenic is highly toxic and it needs proper recycling. You know arsenic, perhaps some villages in India, so many people have died once in West Bengal due to this arsenic in water. So arsenic is very poisonous. So we need to make a very that is proficient or efficient recycling. Now, these are some techniques. First, what we'll need organic solvent dissolution. First technique for recycling. Then organic solvent and ultrasonic irradiation. Then electrothermal heating. That these are all in industry how they use for solar photovoltaic module recycling. Then mechanical separation by hot wire cutting. Then pyrolysis, this is again a process. Then solvent using nitric acid. Then physical integration, dry and wet separation, thermal treatment, two-step heating, then chemical etching. So these are some methods how we can recycling this solar photovoltaic module. Now mathematical modeling, we are coming to mathematical modeling. So now we are coming, so many of you knows about MCDM, again, multi-criteria decision making. So what we need there? One, a error. First you have to have a goal, then there should be some criteria, then alternative. For example, if we go for purchasing a car, say I am going to purchase a car, say my budget is 10 to 20 lakhs. So first what we will do, any idea? Directly we will go to any showroom and purchase, or we will do some research. So how? What is the base thing? So we will fit some criteria. क्या क्या हमें चाहिए है क्या नहीं? तो क्या क्या हम देखेंगे? For example, what should be the criteria? Cost, number one. Mileage, second. Then sitting capacity, safety, power, design, features. Yes. Now features is very important because new generation, like in our time, it is not like that. The new generation like features, so where there is maximum features. और क्या होना चाहिए? So make, someone may be interested. Family, family opinion. So now there will be, we will have some criteria about that. है क्या नहीं? Now after criteria we will have, so basically these are the criteria and we have some alternative कि मुझे 10 to 15 lakhs में ये हमने चुन लिया कि इस 5 गाड़ी में से एक गाड़ी खरीदना है. We have to purchase. We have first shortlisted within 10 to 20 lakhs. Now we have 5 cars in our shortlisted terms. Now based on this criteria, which is best we need to find out. So this is simple answer. Now, in case in earlier in SETI, perhaps in 1976 or 1996, SETI there is a scale. So based on every criteria, some scales is there. For one alternative, what is the criteria? What is the degree of this? 1, 3, 5, 7. Have you gone through SETI scale? Anyone who are doing MCDM? You know SETI scale? You can go to Google and find SETI scale. This is very based on that. Then MCDM has evolved in that way. Okay, there is a scale, SETI scale. But in SETI at that time, what he has done based on that is the Cripps mathematics. But human mind is not Cripps. Again, human mind is always fuzzy. Always we are in dilemma. We cannot give a number to say from this car to this car, my rating is say 3. So my likeness is 3. I can say good, very good, medium, average, this kind of linguistic variable generally. If I ask someone what is the comparison from this car to this car, what is your opinion, which is good, or how is that? Give a number. So before giving a number, or instead of giving a number, one can say, yes, this is good from that car, or this car is very good from that, based on his experience. Say if I asking someone who is using these cars, both the cars, say we have 2 cars or 3 cars in shortlisted category, and one person who are using all 3 cars, so he can give us a very good judgment. So when I ask him, so he will be always in fuzzy, he may not be given directly. That's why fuzzy has evolved in this way. Because nothing is actually creeps in this world. Again, except few things, nothing is creeps in the house. How are you? If someone asks you, what will you say? How are you? Good means there is no any problem. You are good one. There is no problem in your life. You are absolutely good. There is no health issue, no family issue, nothing. Always there will be problems. So good is yes. So see, so when we say good, it is again a fuzzy term. है कि नहीं? तो वो बच्चे जब एग्जाम देके निकलता है भाई कैसा हुआ तो क्या कहते हैं ज्यादातर बच्चे ठीक so that ठीक is so for that ठीक someone is getting 100 out of 100 and some getting 40 out of 100 so that ठीक is again a fuzzy concept so nothing is fixed in the world again so we have to go for fuzzy so that's why we need this thing again and again. So first, there is a dilemma in some researcher who is working in this field. So this hierarchy, two group of people are there who think that first goal, then alternative will come, then criteria will come. But this is a small group. Maximum group says this is actually this has been taken from somewhere that I have copied wrong. First, there should be goal. Then criteria, then there should be alternative. Because हमें खरीदने से पहले, decision लेने से पहले, which alternative will be best for us, we need to check about on the criteria. So criteria will come first. ठीक है? So first goal, then criteria, and then there should be alternative. So now there will be multiple decision makers. So decision maker 1 to P or whatever you give your numbers. Now this is our multi-criteria group decision making. This is the hierarchy. Now fuzzy multi-criteria group decision making. We are what we are talking about now. Fuzzy here we are not discuss about fuzzy. Actually, we discuss about here pure and ortho-pair fuzzy. So when fuzzy has come, then there is a question. So what is the fuzziness in this fuzzy? How much fuzziness is there in fuzzy? Again, that is a big question. Then so many variant of fuzzy has started to come. First, type 2 fuzzy. So in type 2 fuzzy, I think you know about this thing, type 2 fuzzy, that is the membership is again a fuzzy thing. So in this way, in 1986, Atanasov has given a intuitionistic fuzzy set, concept of intuitionistic fuzzy set. So in fuzzy set, what we will do, there is a membership. Again, in fuzzy set, मतलब an element in creep set, what in set theory, what we do, the creeps, there is a characteristic function. So either it will be a member or not. So either its membership is 1 or 0. There is nothing in between. But in 1965, the other said that this is not possible. In maximum cases in real life situation, neither 0 and 1 logic do not work. Again, so then fuzzy set, matlab, there will be like just ठीक है, you are good. So good with a membership 0.7. Someone is good with a membership 0.8. Someone is good, a membership is 0.65. Someone good, or it may be 0.9 or 0.95. कभी-कभी ऐसा टाइम आता है ना लाइफ में कि सब कुछ ठीक ठाक चल रहा है. So that is good. And sometimes good is even 0.2 or 0.1. ठीक है, कुछ भी ठीक नहीं जा रहा है. आते हैं ना टाइम पे, लेकिन कोई पूछता है तो क्या कहते हैं, भाई ठीक है, ठीक हूँ, बोलना पड़ता है ठीक हूँ, लेकिन कुछ भी ठीक नहीं हो रहा है लाइफ में. सो एट दैट टाइम दिस गुड इज 0.1. So now in 1986, so there is a membership. So ultimately, if 0.6 is membership, then non-membership will be automatically 0.4. Or if 0.65 is membership, non-membership is 0.35. Now, Atanasov in 1986 said that no, non-membership cannot be 1 minus membership directly. There will be just certain situations where membership plus non-membership may not be 1. So, for example, I am giving an example. There is an election. There is 2 candidates. So, A has got some votes, 60% vote, and B has got 30% vote and 10% did not cast their vote. So what is the membership of A? 0.6. Membership of B? 0.3. So non-membership of A? 0.4. So we are taking that those did not vote, they are all against A. Is it possible? Clear or not? So who has voted for B, we can say they are against B, they are against A. But who did not vote, are all of them are against A? So how then membership plus non-membership can be 1? So there will be a hesitancy. This 10% did not vote, there is a hesitancy. So there is a hesitancy. So membership plus non-membership is always less than equal to 1, not equal to 1. When it is equal to 1, then it will be a simple fuzzy set. So intuitionistic fuzzy set says that membership plus non-membership is always less than 1. Okay. So, and there that 1 minus membership plus non-membership, say for example in this case 1 minus 0.6 minus 0.3, this is equal to 0.1. This 0.1 is called hesitant. Okay. So this is intuitionistic fuzzy set. Then in Yagar in 2013, he said that I have asked some expert about something, say about some methods. So what is the advantage of this method? So he says that it is say 0.7. And what is the disadvantage? He thought and said this is 0.4. Now this is 0.7 plus 0.4, it is 1.1. So how that can be modeled? Because membership plus non-membership can never be greater than 1. Maximum it will be equal to 1, but here we are getting that 0.7 plus 0.4 is greater than 1. So it cannot be modeled in mathematical. Then he said this kind of situations can often come. If even someone asks you, sometimes you can say yes 0.7 and then non-membership is say 0.5. So what he said, he has devised another fuzzy set. It is called Pythagorean fuzzy set. He said no, membership plus non-membership may be greater than 1, but membership square plus non-membership square must be less than. So now 0.7 square plus 0.4 square automatically it has come. So less than 1. Now you can go to, someone can go to cube like in Senapati and Yagar in 20, they have used Pythagorean Hermitian fuzzy set again. Then that is membership cube plus non-membership cube less than equal to 1. Then someone can go 4, 5. So it will be a never ending method again. So this is not that is a good study. And as a student of mathematics, we always try to go for generalization. So in 2017, this Yagar again has defined Q-rank orthopair fuzzy set. So he said that this membership to the power Q plus non-membership to the power Q is less than equal to 1. So Q is any number. Now, if we can get a theory based on this Q, and this Q is, you can put Q equal to anything, then it is a generalized form. So we don't need to go for then Pythagorean, Hermitian, etc., etc. Then somebody can give another name in whole to the power 4. Yeah, whole to the power 5, somebody can give another name. So now it is Q-rank orthopair fuzzy set. So our theory, this model is based on Q-rank orthopair fuzzy set. That is, membership power Q plus non-membership power Q is less than equal to 1. Okay. This is Jade, this is Atanosov, this is our Yagar. So this is Q-rank orthopair fuzzy set, Yagar in 2017. The Q-rank orthopair fuzzy set over a underlying set. So we know defining a fuzzy set that we always need an underlying set. So a Q-rank orthopair fuzzy set over the underlying set is defined as F equal to X. X is the member, then mu Fx is the membership, X is the element, mu Fx is the membership, and sigma Fx is the non-membership. So where mu F is a function from X to 0, 0, 1, and sigma F is another function from X to 0, 1. And 0 less than equal to membership power Q plus non-membership power Q less than equal to 1. And this difference cube root of qth root of 1 minus mu f to the power qx minus sigma f to the power qx. This is called degree of residence. Now, every time you have to write this x comma mu fx plus sigma fx, not it. So this is a problematic. So what Jaeger has said that let us make it simplified and we will write only for f equal to mu and sigma. So we will consider that there is an element always and its membership is mu and non-membership is sigma. Okay, so only by mu sigma we are omitting or keeping writing x every time. So only whenever we will say that mu sigma, so we will understand this is an Q-rank orthopair fuzzy cell. Now there are some operations. If you are interested, you can go through this. My presentation is with Mukesh sir. You can collect it. Okay. So these are some operations. How that is complement. Complement is that mu sigma is our set. So इस complements क्या होगा? Membership हो जाएगा non-membership, non-membership हो जाएगा membership. That is the complement. So similarly, addition, generalized addition. So this is q1 power q, q2 power q minus q, mu1 mu2, mu1 power q plus mu2 power q minus mu1 mu2, and then for non-membership just product sigma 1 sigma 2. So these are some definitions. You can go through. You can check. This is scalar multiplication. See, the scalar multiplication is a bit different than other in Q-rank orthopair fuzzy set. Kf is qth root of 1 minus mu power q whole power q. This is qth root of this and only sigma power k for non-members. So these are the operations. Now aggregation operator. Why aggregation operator is used? Any idea, anyone? To aggregate, because we are going for group decision making. So group decision making means decision maker will be more than one. Okay, say I have taken 3 decision maker. So first decision maker will give a result, second decision maker will give another result, third decision maker will give another result. So we cannot say these are 3 results. We have to aggregate this result to finally say yes, this is our result. Again, so when we use a group decision making method, we need a device which will integrate the final result. So that's why we need aggregation operator. Okay. So this aggregation operator, what is an aggregation operator? Mathematically, the unification of the inputs provided by multiple decision makers to a singular input is done by a aggregation. Now, what is weighted aggregation operator? Because weightage may not be same for all decision makers, so we have to give some weightage to one. Say we are doing we can say that car purchasing. Okay. Now I have used some the user, and I have used an engineer who are for last 10 years who is working on automobile engineering, and we have taken 2 user and 2 such engineers. So can the weightage of those automobile engineers will be same as a simple user? So we have to give some weightage, higher weightage to those automobile who are last 10 years or 20 years working in that field. So that's why we need weighted. So when more than one will be like weighted mean we need weighted aggregation operator. Now what is a fuzzy aggregation operator? Same thing, there will be the value in general aggregation operator, there will be crisp values. In fuzzy there will be some linguistic variable which we need to formulate in our fuzzy, which fuzzy we are working on. So in that fuzzy we have to convert it, and then finally we will use this aggregation. Now these are some well-known aggregation operator. First, in Q-rank orthopair fuzzy I am talking about. In other fuzzy also there are a lot of aggregation operator. In Q-rank orthopair fuzzy there are some aggregation operator like first Q-rank orthopair fuzzy weighted averaging operator. Then in 2018 again Q-rank orthopair fuzzy weighted geometric operator, first weighted averaging operator and then weighted geometric operator. Then in 2019 Jana et al has given Q-rank orthopair fuzzy Dombey weighted averaging operator. Then Q-Rang orthopair fuzzy weighted Dombey weighted geometric operator. Then Saha et al. They have given Q-Rang orthopair fuzzy weighted fairly aggregation operator. So now we are working on Q-Rang orthopair fuzzy weighted geometric operator. Now how it is defined? Now say these are F phi is some Q-Rang orthopair fuzzy set, nu I sigma I. They are Q-Rang orthopair fuzzy numbers because fuzzy is set to we need to convert to fuzzy number, and then these are weightage. W equal to W1, W2, Wn are weightage such that summation of Wi equal to 1. Weightage should be always, sum of the weightage should be always 1. Then the aggregation operator is a function from Fn to f to the power n to f, and this will be defined in this way. Product of mu I to the power Wi, okay, product of mu I to the power Wi, and then root over of qth root of 1 minus product of 1 minus sigma I power q whole to the power w. In this way, we will aggregate the different opinions of the experts or decision makers. Now, advantages of Q-Rang orthopair, because why we have taken this that is aggregation operator, because there are some advantages. What are the advantages? So first, Q-Rang orthopair fuzzy geometric operator is less sensitive to extremely light values, lower values, preventing over influence of any criterion. So that one, right, if somebody changes at the last time, or one criteria is its value is higher than the other, or we have used some changes, it will not influence on the whole thing. Then reflects the significance of poor criteria in final aggregated value by reducing the value significance. So same thing to poor criteria hoga, so that can be easily reflected within this calculation, that will be reflected that this criteria is very poor, so we can weighted for that criteria will be in that way. Then Q-Rang or fuzzy weighted geometric operator is good fit for risk. So for these problems, the expert has taken that, researcher has seen that for this kind of problem, this algorithm, this aggregation operator works good. So this will be good fit for risk assessment, reliability calculation, clustering analysis, etc. Now reduce subjectivity. So this is a very huge problem in MCDM. So subjective analysis is that is effect in almost every MCDM problem. So this aggregation operator reduce this subjectivity. Now enhance computational simplicity. That means the we know computational complexity. Computational complexity is a huge problem. Not it, because it will take time, it will take cost, it will take everything. So it will reduce your computational complexity. You know, so many of you, I think you know how to find computational complexity. Any idea what is computational complexity? With order of O, we write something. In simple words, so okay, so who generally in coding, who computer science student or student who are generally use coding in their method, they know this thing, what is the computational complexity. Not only that, so there will be number of variable, number of steps, number of calculations in a certain step. So it depends on so many things. Actually, when you code it, it depends on the number of loops. So this reduce computational complexity. Now there is another thing called score function. Now you have finally you have some fuzzy numbers. Again, so fuzzy numbers here our numbers have Q-Rang orthopair fuzzy numbers. So Q-Rang orthopair fuzzy numbers, one Q-Rang orthopair fuzzy set is 0.5, 0.4, another is 0.5, 0.45, another is say 0.55, 0.41. So like this. Now which fuzzy set is better than other fuzzy set? Which Q-Rang orthopair fuzzy set is better? We don't know. We have no idea. When fuzzy is there, we generally directly we cannot say that this fuzzy set is this fuzzy number is better than that fuzzy number. Okay. So for that we have to devise score function. So here a score function has been devised, and the score function, this is our score function. We have defined in this way in that paper. So this score function of a fuzzy number f is 1 by 410 hyperbolic 1. Now, why this? There is huge study. There should be this score function should always just satisfy some properties. We have seen that they are satisfying all those properties, and finally we have use this one. These are the properties of a score function. This score function of 0, 1 should be 0. Score function of 1, 0 should be 1. The score function is monotonic increase, should be monotonic increasing and decreasing with respect to mu and sigma. If you think about mu, it should be monotonic increasing. If you think about sigma, it should be monotonic decreasing. Then, if you have two functions, two fuzzy numbers, mu1 sigma 1 and mu2 sigma 2, with mu1 less than equal to mu2 and sigma 1 less than greater than equal to sigma 2, then score function of f1 will be less than equal to score function of f. So if this property is satisfied by a number, then you can say by a score function, then you can say it is a good score. So we have defined in this way. Now actually our work was based on a fuzzy distance measure, Courant orthopair fuzzy distance measure. We have got this scale, that is the value, the weightage of the alternative by this distance measure. So we have defined a distance measure in this. You know distance measure of two fuzzy set. Why we find distance measure of two fuzzy set? Because how we find distance of between two sets? Any idea? Normally mathematically the two set, we have two sets. What is the distance? Euclidean distance. So many distance measures are there. So it is very easy in our normal set to find the distance. But in case of fuzzy set, this is very much tough. What is the similarity or dissimilarity between two fuzzy sets? To mathematically express that, we use distance measure. Okay. So how much similar and how much dissimilar are they? So there is a function. We have two Courant orthopair fuzzy numbers, and the distance measure between these two Courant orthopair fuzzy numbers of this. So we have defined in this way. So this is a big one. So there is no justification to read it out. Again, just you check it. This is the way we have defined that. Then now again distance measure. How to define a distance measure? There should be some criteria or some conditions which should be satisfied by that by any distance measure. These are the properties. For any two Courant orthopair fuzzy number Q1, Q2, the distance should be always between 0 and 1. Then distance between two fuzzy number is 0 if and only if Q1 and Q2 equal to Q1 and Q2. And this actually in this point number 2, maximum distance measure lose their importance, because say so many definitions are there. They use say membership minus non-membership. Now, whenever you are using membership minus non-membership generally, or square of membership minus non-membership, or cube of membership minus non-membership. So, in score functions also, in distance measure also, in literature you will find there are a lot of this kind of score function and distance measure. But the problem is, if a set is say 0.5, 0.5, so whenever you are taking difference or difference of any powers, that will be 0. Now another set say 0.4, 0.4. So again the result is same. Again say 0.3, 0.3 or 0.6, 0.6. So again the result is 0. Again, so whenever we are taking in this way, but this 0.5, 0.5 a fuzzy set, 0.4, 0.4 is another fuzzy set. These two fuzzy sets are not same, but this somehow due to some disadvantage in the method, we can find that the result is showing that they are same. So then dq1 q2 equal to dq2 q1. Now if q1 subset of q2 subset of q3, then dq1 q2 is less than equal to dq1 q3, and dq2 q3 is less than dq1 q2. Now for an arbitrary q1, the distance of that Q1 and its complement is 1 if and only if Q1 is fixed. Otherwise, it will not be 1. Then dQ1, Q2 is equal to distance between two fuzzy numbers will be equal to distance between their complement. Then dQ1, Q2C is dQ1C, Q2, or for any Q1, dQ1, Q1C equal to 0 if and only if mu1, y1 equal to sigma 1, y1. Matlab, its membership equal to non-membership. Now, we'll use in our problem, that is in solar photovoltaic module recycling technique, this method. Now, these are our criteria: operational cost, material reclamation, greenhouse gas emission, operational needs, manpower, skill manpower, waste volume reduction, infrastructure, operational hazards, delamination period, cell damage, energy requirement, ecological effect. These are our criteria for solar photovoltaic module. Now, any criteria in so many methods of MCDM can be divided into two ways, in two sections. One is cost criteria, one is benefit criteria. Okay, beneficiary and someone say non-beneficiary. Non-beneficiary, some people say cost. Okay, so which criteria are beneficiary, which criteria are cost criteria, non-beneficiary criteria? This is very easy. Which is actually, if it is bigger, then this is a disadvantage. Then this is cost criteria or non-beneficiary. If it is bigger, then if it is good advantage, then it is a beneficiary criteria. ठीक है? For example, operational cost. Operational cost जितना ज़्यादा होगा क्या होगा? Benefit or not, advantage or not advantage? Disadvantage. So this is a cost criteria. Now material reclamation. जितना material reclaim कर सकता हूँ वो क्या होगा? अच्छा होगा या benefit और non benefit? Benefit. So this is a beneficiary criteria. Same way greenhouse gas emission. जितना ज़्यादा होगा क्या होगा? Disadvantage. So this is a cost criteria. Operational need, the necessity and basic instrument requirement, beneficiary. Skill manpower आपके पास है तो क्या होगा? Beneficiary. Waste volume reduction जितना reduce होगा? Beneficiary. So these are divided into cost and beneficiary criteria. ठीक है? All criteria can be divided in this way. Now we have taken actually 4 decision maker and 2 were from academic. One is from physics department, another is from electrical engineering, and we have taken 2 experts from industry who is working on the same field. So then there we have given a 5-point scale where very low, low, moderate, high, and very high. We have formed a questionnaire and we have sent them to say which criteria is how much they are giving importance to which criteria. So C1 क्या था? Operational cost. ठीक है? So operational cost, see the decision maker 1 ने दिया 8, decision maker 2 ने दिया 8, 3 8 and 4 very high. So high, very high. So ultimately पैसा important है. Whenever you are going to introduce a plan, the money is much important. ठीक है नहीं? So that's why it is high. So similarly, what was C2? Amount of material recovered. That is material reclamation. So that is most important. Why we are doing this recycling? To get this material, reclaim the material. So now see, in first 2 decision maker, they have said that very high, and decision maker 3 and decision maker 4, they have said that these are high. So in this way, all these criteria has been given some linguistic variable by 4 decision makers. Okay? So, and these are based on this 5-scale, 5-point scale. Very low, low, moderate, high, and very high. Now these are our 5-point scale, and this is the corresponding Q-rang orthopair fuzzy number. So very high, when it is very high, this is 0.95, 0.04. For high this, for moderate this, low this, very low this. Now we have taken, see, you can see if it is Q-rank orthopair fuzzy set, we have taken 0.75, 0.25, 0.5, 0.5, 0.3, 0.74. We have tried to make, because Q-rank orthopair means Q may be anything. Again, Q may be even 1. So that's why we have taken in this way. This is a standard procedure, though, in Q-rank orthopair fuzzy set. So this 5-point scale can be written to convert in this linguistic variable to Q-rank orthopair fuzzy number. Now next, that is this Q-rank orthopair fuzzy weighted geometric operator based stepwise SWARA method. So you have already, I think, so many of you have heard about SWARA. Again, there is an MCDM method called SWARA. So we have used SWARA method here. So calculation is there. If someone interested, we can show it. Now first let us go through. Then if someone is interested, we will discuss. Now scale the criteria in table 2 according to their importance using table 3. So this is table 2. This is table 2. So now high तो नहीं चलेगा, mathematically high तो हम कुछ नहीं कर सकते हैं ना. For to mathematical calculation we need some number. So just put it as point. So when this is very high, put 0.95, 0.04. When high, put 0.75, 0.25. Then aggregate the assessment collected from decision makers. Now already we have used aggregation operator. We know what is the formula. So using that formula, aggregate the assessment collected from decision maker using Q-rank orthopair weighted geometric operator, and then compute scores of Q-rank fuzzy numbers using score function. So we have first computed, we have aggregated. So after aggregation, we have got a fuzzy number. Now for a fuzzy number, there is a method how to find the score function of a fuzzy number. So using that score formula, we have obtained the score function, score value of that Q-rank orthopair fuzzy number. Now arrange the criteria according to their score value in descending order. Now we have got all score functions. So based on the descending order, let us arrange them. Now find the comparative importance of criteria from defuzzified value, which indicates how important the jth criteria is concerning the j plus 1 criteria. So first, from first to second, what is the importance? From second to third, what is the importance? From third to fourth, what is the importance? So just find it by this formula. As j plus 1 is less important, minus j plus 1 is important from that table. Now, what we have taken here, note all the decision makers. Here we have given equal importance to all decision makers. Okay. Why? Because two are very learned person, researcher, who is working for so many years on this solar photovoltaic module, and two are working in the industry. They are also experienced person. So all are almost same category. That's why we have given equal weightage to all those 4 persons. So since 4 persons are there, and we know summation of weightage is equal to 1. So for all, the weightage is 0.25. Now step 6, evaluate coefficient values of criteria by now coefficient value. Now Cj equal to 1 for the foremost value of Sj and Sj plus 1 otherwise. So similarly calculate the corrected value of weight. This indicate the measure of weight. The jth criteria carry with respect to j plus 1 criteria. This is rho j. So rho j is 1 if Cj equal to 1, otherwise rho j minus 1 by Cj. Now final weight will be Wj equal to rho j by summation of all those rho. Now this is after evaluation, we have got that this criteria, evaluated criteria weights are for C1. The first criteria has got a weight of 0.1, C2 is 0.104. So these are the weights for first criteria, second criteria, third criteria. Okay, based on the degrees or expertise value what they have given, what they have mentioned, that which criteria is how much important. Based on that, we have seen that this is our weightage. So you can see that the C2 is the highest weightage or no? It is highest weightage. Yes, C2 and C12. So what was C2? Reclaim. So almost C1 is also almost same. So what is C1? First. And what was C12? Let us see. The C12 ecological effect. Ecological effect, because that's why you are doing. Why we are recycling it? To minimize the environment effect. Again, so ecological effect is highly important. So our weightage that confirms that what we have thought earlier, that is given in the weightage. Now this is just a graphical form. Now this is criteria alternative. Based on criteria and alternative, again we have made an questionnaire. So is it visible? Okay. So based on say criteria 1, based on alternative 1, what is the value of different criteria? Okay. So based on alternative 1 क्या है? Alternative 1. These are alternative. Alternative already we have seen, that is what are the methodology for recycling, photovoltaic module recycling. क्या क्या था method? Chemical etching. Then that we have written in order to show which is coming first, second, third in that way. So we have shown what are the alternatives. Let us see. Because our work is recycling. Again, so since our work is recycling, what will be our alternative? Recycling techniques. If we want to purchase a card, what will be our alternative? The different cards. Again, if we want to purchase a computer, what will be our alternative? The different makes of computer. So our work is there to recycling. So what will be our alternative? The different recycling technique. So what are the recycling techniques? These are recycling. This organic solvent dissolution, organic solvent ultrasonic radiation. So 6, 5 plus 5. So 10 alternatives are there. So this is the table based on okay. So just remember, we need to remember, just for remembering, these are A1, A2, etc. Okay. Chemical etching A1, these are A1, A2. In this way, we have CE, chemical etching. So in this way, we have named this A1, A2, A3, etc. So for the first alternative A1, okay. So for the first alternative A1, क्या था? Chemical etching. Say. So for the chemical etching, what is the value of different criteria? So what is, how much important is the first criteria क्या था? Cost, functional cost or operating cost. So based on this chemical etching, what is the importance of first cost, operational cost? So this is first जो decision maker one है, he has said this is very low. मतलब chemical etching में ज़्यादा पैसों का जरूरत नहीं है. So this is very low. Then C1 was material reclaim. तो chemical etching में moderate, मतलब इतना ज़्यादा material recycling नहीं होता है, reclaim नहीं होता है. So similarly C3 for extremely low, C4 for very low. So in this way they have given rating based on 9-point scale. These are 9-point scale. Extremely high, very high, high, moderately high, moderate, moderately low, low, very low, extremely low. Okay. Here we have divided the 9-point scale. So based on that 9-point scale, we have formed a questionnaire and we have sent it to experts and they have given this table. Is it okay? Now this has, now we need to this, we need to convert this, that is this values, linguistic values to Kurang orthopair fuzzy numbers. So these are extremely high is 0.95. These are our linguistic values. Okay, converting to linguistic values to Kurang orthopair fuzzy numbers. Now this distance measure base. Now here we are ranking used in that for criteria we have used Swara method, and for alternative we have used that the new distance measure we have already defined. By that distance measure based ranking method we have used. Now first step one is these steps are important in calculation. So if you want to know how the calculations are done, so we can take other. So just let us see. Calculate the aggregated values from the assessment of each decision maker using Kurang orthopair weighted geometric operator. Stated again aggregated value. All these are there for C1, C2, everyone is there. First we need to make them aggregated. Okay. Then there will be a matrix which is Pij, Qij. How to find? Where M stands for the number of alternatives and N stands for number of criteria. So we will how many alternatives are there? We have 10. And how many criteria are there? 12. So we will get a 12 by 10 matrix. So step 2, the criteria are of two types. Already you have seen beneficiary criteria and cost criteria. To make now, if both type of criteria will be there, then calculation will be difficult. So we need to make them all in same type of criteria. So if there is cost criteria, either take all in cost criteria or take all in beneficiary criteria. How to make it? Because see, if your criteria is cost criteria, if we take complement, what will it be? Beneficiary criteria. And how to take a complement in a Kurang orthopair fuzzy number? Just make membership and non-membership interchange. So let us make all these criteria to a single format, either all cost criteria or beneficiary criteria. So let us make it all beneficiary criteria. So the criteria are of two types, beneficiary and cost criteria. To make all criteria are same type, normalize the aggregated matrix as follows. So if it is beneficiary criteria, let it be Pij, Qij. If it is cost criteria, make it Qij first, then Pi. Taking the complement, the cost criteria have been transformed into beneficiary criteria. Now we have weighted normalized aggregated matrix because we need weight. Again, we have seen because we have 4 experts, but though here we have taken the value of weightage of each expert is 0.25. So we have taken all weightage of all experts. So calculate the weightage normalized aggregated matrix under QROF environment using this multiplication operator considering criteria weight. So D dash equal to this Wij into Pij Qij. Okay. So multiplication already you have defined in Kurang orthopair fuzzy set, generalized multiplication. So let us call it Pij double dash Qij double dash. Now evaluate negative ideal solution or positive, any idea negative ideal solution and positive ideal solution kya hai? Who is working in MCDM? What is negative? What is negative and what is positive? Based on all criteria, which is the worst result, that is negative ideal point, and best result is positive ideal solution. So the based on all criteria, which results is worst, that is. So if we want to get, say for example, reclaim, so that is if it is very low, reclaim result is very low, it is worse, and when it is maximum, that is positive. So this is negative ideal solution and one is positive ideal solution. So evaluate the negative ideal solution or the positive ideal solution by calculating score of each element column wise corresponding to its criteria. Because how again? Because except score function you cannot find. Using, you have all the results are based on or in the form of Kurang orthopair fuzzy set, okay, fuzzy numbers. So you have Kurang orthopair fuzzy numbers, so that from that you cannot say which is better, which is worse. So first you need a score function to make it convert it Cripps number. So now score function, using score function we have converted in score Cripps value. Now from that Cripps value you can say which is best and which is worst. Okay. So then in that way we can find positive ideal solution and negative ideal solution, and which is determined by this. Now measure the distance of each alternative performance from this negative ideal solution or positive ideal solution. Then rank the alternative according to their intervening distance from NIS or PIS. Now this is finally, these are the value distance from NIS and distance from PIS. Now what do you think, which will be better? So these are ranking. This chemical etching is 1. See, negative from distance from negative is highest, 0.02587. Okay. So based on negative, the ranking is based on distance from negative ideal solution. So this is 1, 2. In this way we have ranked them. So this first is chemical etching is the best process to recycling the solar photovoltaic module. Then followed by almost same, there is no much difference, by organic solvent and ultrasonic irradiation. Now these are based on the studies based on these 12 criteria and 10 alternatives. Now if and those 4 experts. Okay. Now there may be now every day new studies are coming. So you can find there may be some more criteria and there may be some more alternatives. So you can incorporate them and you can find them. So this is graphical method. This is alternative performance with respect to negative ideal solution, and this is alternative performance with respect to positive ideal solution. So results and discussion. This is since this is a research paper and we know the most important part of a research paper is results and discussion. So we need to know. So mechanical design, disassemble, what they do, mechanical reassemble. How to make it? So just remove this aluminum frames, junctions, box, etc., etc. Take class layer. Then delamination. So what method? What is we have got 10 alternative. Na? So this is the which method? How which method was? This is just okay. Alternative. The that is details of the alternatives. First, mechanical disassemble was one method. This is how that go. Then delamination. Then chemical etching. Then solid and liquid disassociation. Now advantage of chemical etching. So chemical etching has been got for the first priority. So what is the advantage of? Now high priority recovery of valuable metals. What is the benefit? High priority high purity recovery of valuable metals like silver, aluminium, copper, anti-refractive coating, etc. Silver recovery rate often exceeds 95 to 98% by this method. And high purity silicon wafers recovery with controlled etching and silicon flake recovery allows refurbishment over destruction. So we can make it again, we can use it again. Lower energy consumption compared to thermal processes, also cheaper and greener than thermal processes. Avoids toxic gas production and emission in the environment. Why this has been got the first ranking? Fewer steps, need fewer components, chemical reagents, and compatible with industrial large scale solar photovoltaic module recycling. Boost the circular economy. Now organic solvent, this was for a second one. So what is the benefit of this? No, how this has been done? Mechanical deassembling, cut into manageable organic solvent in ultrasonic radiation. How this has been done? This is given here. The methods. Advantage of this: use green solvents like D-limonene energy efficient process. It came second. That's why operating control temperature, avoiding thermal damage to the cell. Faster EVA separation due to ultrasonic radiation, and removal of EVA layer happens without burning, causing no toxic gas emission. Good at protecting silicon wafers for refurbishment. High quality glass silicon wafers backseat recovery. So solvent can be easily distilled, filtered and reused, improving cost efficiency and support circular flow. See, first and second, both why first and second, they can give us maximum reclamation and their environment effect is minimum. So these are with different method we have checked the ranking of alternatives. We have checked by different method like SAW method, WASPAS, TOPSIS, ADAS, MURA, CODAS, COPRAS, WPM, RAS, FOCOSO, MARCOS, TODIM. So with so many methods we have checked and we have seen that almost except FOCOSO, almost similar ranking FOCOSO and TODIM. So the remaining methods are very much. So though in CODAS and COPRAS they are not 1, 3 and 3, but see second is 1. Okay, so almost there is a relation, good relationship. If we find say correlation coefficient, we will get that correlation coefficient is more than 90% except FOCOSO and TODIM. So these are some odd results. It is not matching with our result. So this is just graphical representation. So this is comparison. Now ranking alternatives. Now we have worked with Q-rang orthopair fuzzy set. Again, so Q value for different Q value, the result is in proposed method. Actually, we have taken Q equal to 3. The calculation we have made because if you put Q, then you cannot calculate the things. So you need to put some value of Q. So in our work, we have put the value of Q as equal to 3. And we have got the same result with Q equal to 1, Q equal to 2, up to Q equal to 10. So we have seen these are up to Q equal to 6. The results are 1, 1, 1, 1. So some differences are there. So up to Q equal to 6 or 8, the results are comparable, but after the not 6. Still up to Q equal to 6, these results are comparable. After that, because the first has come here in 4. Q equal to 6, these results are comparable. And actually that is good because you cannot take say membership as 0.8 and non-membership as 0.9. Again, or membership as 0.85 and non-membership as 0.75. This is not possible because then also if we take 10 to point power 10 or whole power 7, this will be less than 1. So it is not possible that I am taking the membership as 0.8 and non-membership is 0.7. It is not possible because non-membership is sometimes some confusion may be there, 0.8 and 0.4 may be there or 0.3 may be there, but 0.8 and 0.7 it is never possible. So graphical evolution for Q equal to 1 to Q equal to different value of Q. Now conclusion. So analysis, just what we have done. I just not going to read this out. Just you can see. Now in SPVM recycling industry in India, this is in Hyderabad, Sustainability Limited. Then this is Vikram Solar at Kolkata. This is Tata Power Solar in Bangalore. This is Topsam Energy, Gandhinagar. This is Sterling and Wilson Renewable Energy, Mumbai, and Applied Solar Technology. But these are very few. What we need in next 20 years, these are very few. We need some hundreds of such installations for such companies and such industries. So future scope of research, who are interested, now researchers can explore the area of SPVM management procedures, how to manage those in future because these are coming daily, how to manage this. So predictive modeling, first start work from prediction, how much these are coming and how if we work in this way, what will be the prediction. So how many percentage of this solar modules will be recycled? Then a review research, this is always a good work if for early researchers. Review research over social, ecological, and political barriers and further involvement in SPVM. The area of ultrasonic and laser assisted delamination is very less explored. So here we have not done that. You can check that ultrasonic and laser assisted delamination. Then recycling of the solar photovoltaic technology, which are still under experiment scale or not yet largely commercialized. So still works are going on. How can the maximum thing is the two factor you need to remember. One is reclamation. Second is minimizing environmental effect. So there are so many methods still are going on. So you can work on those things. Then chemical etching using green solvent. Now we are using some chemical, you can think about some green solvent. Then zero waste, perhaps, I don't know when it is possible, zero waste. So can be thought about that. Now these are some references that we have gone through to find different methods, especially different recycling methods, and the works of Curang auto care for detail. So if word file है ना, word file तो पूरा दिखाइए, एक word file है. See, we have shown here. Yes, नीचे कीजिए, नीचे कीजिए. See, these are for first one we have shown here how the calculation can be done. The first one we have seen the first C1 H and VH was given. So we have first put these values for H, that was 0.75, 0.25, and then we have used Curang orthopair fuzzy weighted geometric operator. This is the formula 1 minus Q1 to the power this W1, 1 minus Q2 to the power W2, 1 minus Q3 to the power W3, 1 minus Q4 power W4. And similarly, sigma, and so finally we have seen this equal to 0.79, this membership is 0.795658 and non-membership is this. So you can see, so this, then next. So just I have shown by one criteria. Okay. So this is the score function of the first criteria we have got 0. This formula we have applied and 0.8347. So in this way we have to find all score functions and we can find the weight of the next. So this is alternative. So for the first alternative, the operating cost for different member, first alternative A1, so C1 has been given as very low. Can you remember? This was very low, medium, low, and medium for operating cost for the first alternative. And weight we have taken that weightage are all 0.25. Then this is operating cost for very low. We have taken this one. For medium, we have taken this one. For low, we have taken this. So in this way. Next. Okay. So by the same method, already we have discussed how to aggregate, how to find that is membership and non-membership. We have got membership and non-membership, and then these are membership and non-membership of alternative A1, A2, A3, A4. In this way, we have found the criteria for all alternative for criteria 1. Okay. So in this way, for all alternative criteria 2, criteria 3, criteria up to criteria 12, we need to find out. So then next. Now C1 कौन सा criteria था? First criteria. So क्या होगा? Ultimately come. So this we have got come. So this is weighted normalized value. We have got this. This is the formula. Can you remember? We have said what is the formula for this scalar multiplication? Root over of 1 minus UF root of 1 minus Okay, so this formula we have used the cube root of. So we have said that for calculations here we have used q equal to 3. So cube root of 1 minus 0.66083 whole cube whole to the power its criteria weight 0.0998594. So in this way we have got weightage normalized value. Next for A1, A2 up to A10. So now this weighted normalized value from weighted normalized value from we need to compare, we need to find store functions. So we have got four all I have shown only for C1. So similarly for C2, C3, C4, we need to find out. So these are the score functions. Now see which is best one. This one, and which is worse? This one. So this is positive ideal solution is this one, positive ideal solution is this one 0.44411. This and negative ideal solution is the third one F3 0.2335 and 0.943. Okay, so based on C1 we have got positive ideal solution and negative ideal. So based on C2, C3, C4 etc. for everyone we can find it. Right? So we don't know. So this is a table. So for all criteria and all alternative for alternative A1 we have written here. Now see distance from negative ideal solution and distance from positive ideal solution. Now we have everything. So we have got the distance. Next. Okay, so this was last because from distance we can find we have got the table. We have find the ranking which is worst and which is best. So from here you can see this A1 distance of the NIS is lowest and this distance from PIS is highest in A1. So if we make average, then distance of the first one distance from PIS and distance from NIS, if we take the average, then A1 is the best one. So in this way we have ranked A1, A2, A1. Okay. So we have for ranking here you can take distance from positive ideal solution. So positive ideal solution, in this way we have made the rank. Next, so next one. So in this way we can find we can calculate. So you need just a Excel file and you just need to put those values. We don't need to get for any kind of say coding or anything. Just get a Excel file and put the values. The formulas are simple. Just put those formulas. So first, this is a Curang orthopair fuzzy set. You can use with a initially you can use with a say intuitionistic fuzzy set. So Q equal to 1. So your calculations will be easier to check whether the calculations are working. Okay. So any questions, please? बोर कर दिया.
Question. If you have any question, then we can discuss the questions during the tea session because we are running late and another session has to be started at 4 p.m. So if any one of you have some questions, queries,
we'll discuss.
Okay.
We'll discuss. अच्छा. Yes. It's a tough question. And in that time, in that time it will not be required. It will not be required. For a robot, it will not be required because first you know whether power backup is fine or not. It will detect, since AI is there, it will detect whether its power backup is there or not. So if it is not there, its power backup is not sufficient, it will charge himself. Okay, so AI it will charge himself. तो हमारे जैसा अभी बैटरी चेंज करना पड़ेगा, बैटरी का पावर कितना है मालूम नहीं है, तो इट विल नॉट बी दिस सिचुएशन विल नॉट बी देयर फॉर रोबोट. ठीक है सर हम लोग कर रहे हैं भाई
I am deeply honored to extend a sincere vote of thanks to Professor Apu Kumar Saha sir for his insightful talk on sustainable recycling technology, selection for end-of-life solar photovoltaic modules using Qurong ortho-pair fuzzy decision-making approach. His lecture beautifully highlighted the critical environmental and economic importance of recycling end-of-life solar panels, emphasizing recovery of valuable and toxic materials and supporting circular economy practices. The presentation clarified advanced Qurong ortho-pair-based decision-making methodologies with great precision. On the behalf of Department of Mathematics, I sincerely thank Professor Saha for sharing his expertise and dedicating recovery of valuable and toxic materials advance our and supporting circular economy practices. Now I warmly invite the presentation clarified advanced and Qurong ortho-pair-based decision-making methodologies. The moment with certificate to Professor Apu Kumar Saha. On the behalf of Department of Mathematics, I sincerely thank Professor Saha for sharing his expertise and dedicating recovery of valuable and toxic materials advance our and supporting circular economy practices. Now I warmly invite the presentation clarified advanced and Qurong ortho-pair-based decision-making methodologies. The moment with certificate to Professor Apu Kumar Saha. On the behalf of Department of Mathematics, I sincerely thank Professor Saha for sharing his expertise and dedicating recovery of valuable and toxic materials advance our and supporting circular economy practices. Now I warmly invite the presentation clarified advanced and Qurong ortho-pair-based decision-making methodologies. The moment with certificate to Professor Apu Kumar Saha. On the behalf of Department of Mathematics, I sincerely thank Professor Saha for sharing his expertise and dedicating recovery of valuable and toxic materials advance our and supporting circular economy practices. Now I warmly invite the presentation clarified advanced and Qurong ortho-pair-based
Good evening, all of you.
the moment
Today,
with certificate
the last session of first day of international
Department of
workshop
Mathematics,
on
I sincerely
AI
thank Professor
frontiers
Saha for sharing
fuzzy
his
optimization,
expertise
cyber security and simulations.
recovery
We have last session. For our last session, we have Dr. Neha Yadav from NIT Jalandhar for their valuable talk. Good evening, all of you. Dr. Yadav is in the last session of assistant professor in mathematics and computing and AI frontiers. We are Ambedkar NIT optimization, cyber security and simulations. We have last session in Allahabad. Last session is Dr. Neha Yadav from NIT Jalandhar for their expertise line. Good evening, numerical analysis. Dr. Yadav computing and the last session of assistant professor in mathematics and computing and AI frontiers. We are Ambedkar NIT optimization, cyber security and simulations. We have MNC and FD in Allahabad. Last session Dr. Neha Yadav from NIT Jalandhar for their expertise line. Good evening, numerical analysis. Dr. Yadav computing and the last session of assistant professor in mathematics and received multiple awards, including best paper and cyber security fellowship and community and efficiency in
Okay, thank you very much for such a nice introduction. So, am I audible to everyone? Yes, ma'am. So, thank you so much. First of all, I would like to thank you very much for this international workshop, Professor. Am I audible to everyone? And Dr. Sandeep Kumar and other organizing committee members for inviting me and giving me the opportunity. So thank you so much. First of all, so I believe I joined a little early and I thought that I felt like this workshop is in hybrid